So the next idea I'm going to discuss today is related to working on multiple coordinate system. As I said in the beginning, if you have a problem where you have loads, probably different types of loads, and then you have some boundary conditions here and some boundary conditions here, and you have a coordinate system x1, x2, and x3. You want to solve the problem within this coordinate system. You have pretty much everything written in this coordinate system. However, in some cases, you need to transform between one coordinate system and another coordinate system. Let us assume that you have f written in this coordinate system, x1, oh, sorry. I just tried f1, f2, and f3. And let us assume that you have some stress also, some stress tensor, sigma 1, 1, sigma 1, 2, sigma 1, 3, and so on. Now you want to transform between one coordinate system and this another coordinate system. I'm going to call it x1 bar, x2 bar, and x3 bar. Let us just assume that this is the case. Now to do the transformation, you have what we call the transformation matrix. I'm just going to show you the matrix. So the transformation matrix is basically related to the angles between the old and the new coordinate system. So this is the old coordinate system. This is x1, this is x2, this is x3. Now the new coordinate system is here. This is x1 bar, this is x2 bar, and this is x3 bar, all right, or dash. Now, the component of the transformation, and this is the transformation matrix here. Now, the component of this transformation matrix is basically the angles, or is related to the angles between the old and the new coordinate system. So if you look into the first axis, x1 dash, the first entry here is the cosine of the angle between x1 and x1 dash. If you look into the second entry, it is the angle between x1 and x2. If you look into the third entry, it is the angle between x3 and x1. I'm just going to rewrite it here. So you have the old coordinate system, I use black. x1, x2, and x3, and you have a new coordinate system. Let us assume that this is x1 bar. Now, I'm just going to draw x1, not to complicate things. So the angle, and this is the transformation matrix, I'm going to call it a key. So the angle between x1 and x1 bar, this is the angle, I'm going to call it theta 1. We take the cosine of theta 1, and we put it as the first entry. The angle between x2 and x1, I'm going to call it theta 2. You have cos theta 2. And then the third angle is this one between x3 and x1, and we just call it x. We call it theta 3, and this is cos theta 3. And you repeat the same thing for this one, x2 dash, and for this one, x3 dash. Now, this is how you get the transformation matrix. This is a transformation tensor, actually, and it is orthogonal because it has specific properties. Now, the properties of the orthogonal tensor, you can see them in the discussion in the lecture notes. I'm not going to get into them because it's just some properties, specific properties. Okay, you just read them. Now, to get the vector in the new coordinate system, so basically to get f1 dash, f2 dash, and f3 dash, and I'm just going to call this one f dash. I mean, why wait? Just not to confuse you with the vector concept, I'll probably just use a different color. Okay. So the dash or the bar here I'm using for the vector concept. And then I'm just going to use red for the new coordinate system. I've used the blue, so I'm just going to stick with blue. So this is the coordinate system I have here. So I'm just going to call it F blue. So F blue, F1, F2, and F3. Now F blue and F black, they are related through the Q matrix in this way. F blue is basically F black multiplied by the Q matrix. And if you want to get F black back, you take the transpose and you multiply it with F blue, and you get that. So F black is basically the transpose of the T matrix multiplied by F blue. So you can transform the vector, the force, from one coordinate system and transform it back using the Q matrix or the transpose of the Q matrix. You can do the same thing for the tensors. So sigma is basically Q multiplied by sigma black from left and from right. From left, it is the Q. From right, it is the transpose of the Q. If you want to get it back, sigma black, then in this case, you just have to multiply by the transpose first and sigma, and then Q. This is just a set of rules, all right? It's just a set of laws that you need to remember, and I've summarized them for you in here. I've summarized them in the presentation here. So basically, if you want to transform a vector, multiply it. If you want to transform a vector, multiply it with the Q. If you want to get it back, multiply it with the transpose. If you want to transform a tensor, multiply it by Q and Q transpose. If you want it back, then this one and this one. I'm going to solve an example and things will probably become clear. Let us take this vector V. And this vector projected in this coordinate system, I'm projecting things here. So this length here is 3, this length here is 2, and this length here is 1. So if you want to write it in this coordinate system, you would write in the x1 direction, this is in the x1 direction, you have 1. In the x2 direction, you have 2. In the x3 direction, you have 3. Now, what you did here, you rotated the coordinate system. So you brought x and rotated by 95 or by 90 degrees. So this one has moved, x1 has moved from this location to this location. So x2 would also follow and be rotated by 90 degrees. So it will come here. And then x3 is in the same place because it does is just pointing upward, and the rotation has been around x3. Now, in the new coordinate system, this length would remain 3, and this is, I'm just going to call it V dash. So for x3, it remains the same. This length would still be projection in the x3, where if you look into the x2 direction, this is the x2 direction. This is the length in the x2 direction. It is pointing in the negative direction now, is opposite to the x2 direction, is pointing in this way. And the length is 1, so it is negative 1. And if you look into the x1 direction, it is pointing in the positive direction, and the length is 2. So this is the 2 here, is the same like the 2 here. So the new coordinate system, or in the new coordinate system, V dash should be 2, -1, and 3. This is just looking into the picture. All right? I have not done any mathematics here. I'm just using the logic to analyze how the components would look like. Okay, do you agree with what I've said? Or do you have any questions about what I've said? All right, now let us try and use the math we have learned. So the math we have learned, we said that the angle between x 1 dash and x1, which is this angle here, is going to be the first entry in my cos matrix. So this is 90 degree, so it is cos 90. This is the first entry. I've got no space here. I'm just probably going to draw it here. And I'll probably try to copy the picture over. Exit and copy the picture here. And zoom on that a little bit. All right, so this is x1, and this is x1 old. I'm going to call it a new and old. So the angle here is 90 degrees. So the big matrix here should be cos 90 for the first entry. Now, if you look into x1 and x2, the angle here, this is x2 and this is x1. So the x1 in U is on top of x2 old, and the angle between both is 0. So it's going to be cos 0. And if you look into 3, x1 dash and x3 is pointing upward, and the angle here is basically 90. So it is going to be cos 90. Now we repeat the same thing for all the coordinate system. See, for cos 90, this is going to be 0. This is going to be 1, and this is going to be 0, right? And you repeat the same thing for x2 now. So this is x2, and x2 is related to x1 by 180. So it is cos 180, and then is related to x2 old by 90, and is related to x3 by 90. So it is cos 180, cos 90, and cos 90. Oops. So it will be cos 180, cos 90, and cos 90. So this is going to be -1, 0, and 0. And if you look into the matrix, it's going to look like this: 0, 1, 0, -1, 0, and 0. And for the last axis, x3 is on, x3 is on top of itself. So x3 is here, and it remains in the same direction. So in this case, x3 and x1 is 90 degrees, and x3 and x2 is 90 degrees, and x3 with itself is 0. Okay, Fabian, can you ask the question again? x3 doesn't move, yes. The angle is 90 degrees with what? I'll just write it here and tell me if you agree with this or not. The angle between x3 and x1, okay, so this is cos 90, cos 90, and cos 0. So if you evaluate the cos 90 again, it's going to be 0 and 0, and cos 0 is 1. Oops. All right, I'll probably just use it in the presentation. And if you look into that in the presentation, so this is the Q matrix. Now, if you want to do the transformation, I'll probably just take it into, yeah, I think this is better. So you see the full thing. So this is, I said, 0, 1, 0, 0, 1, 0, minus 1, 0, and 0. And here you have 0, 0, and 1. You have the vector itself. I have written the vector here. No, I have, all right, so this is here is 2, minus 1, and 3, multiplied by 2, minus 1, and 3. So this is going to be this multiplied by 0, minus 1 multiplied by 1, and 3 multiplied with 0. I will be left with minus 1. 2 multiplied with minus 1 is going to be minus 2. No, wait. This is not minus 1. This is 1 and 2 and 3. So this is the vector I'm transforming. This is here. 1 and 2 and 3. Don't have any negative components in there. Just delete this. And delete this. And have 1 and 0 multiplied by 1, 2, and 3. This is 1 multiplied by 0, 2 multiplied by 1 is 2, and then 3 multiplied with 0 will vanish. 1 multiplied by minus 1, this is minus 1, the rest is 0, and then I have 3 multiplied by 1, this is a 3. So it's 2, minus 1, and 3. And if you look here, you'll see that this is 2, minus 1, and 3. This is 2, minus 1, and 3 here. Now, you can transform it backwards by taking the transpose of Q multiplied with V dash. All right, so I want you to apply the transpose and find the new vector, or get back the same vector as you apply the transformation backwards. Okay, so I'll give you 2 minutes and try to get the transformation backwards. The transformation backwards should give you the original vector, which is the one you started with, is 1, 2, 3. Is 2, minus 1, 3. So if you can, I want you to get V through the multiplication of Q transpose by V dash. All right, see, you can't try the transformation backward and forward. You always get back what you have started with. Now I want you to do this example is a transformation of a matrix. Now is a transformation of a tensor. We're going to use exactly the same Q, but to transform a tensor T. Now the tensor T is transformed through the Q using exactly the same procedure. To transform it forward, you multiply it by Q from left and then by Q from right. And to get back what you started with, you transpose the Q and apply it from the left, and you apply the Q from the right as well. So I want you to try and get T dash and get T back from the T dash you started with. And you can see the solution for the forward and the inverse transformation. So you apply the transformation. sorry, you apply the transformation, you get t dash, you apply it backwards, you get what you started with. So this is the same like this one.